Hello everyone. My name is Tae Hyoung Kim. I'm an associate professor in School of Electrical and Electronic Engineering, NTU, Singapore. So today I will talk about tiny machine learning for energy constrained Internet of Things. Artificial intelligence and machine learning has been changing our daily life dramatically. So I believe everyone knows this big event between AlphaGo and Mr. Lee. So AlphaGo is an artificial intelligence playing Go game. And in this event, the previous world champion, Mr. Lee, was defeated by the AI AlphaGo. And it was a very shocking event to many people in Korea and also in many other countries. So after this big event, artificial intelligence and machine learning has drawn huge amount of attention from researchers and research areas and industry. So artificial intelligence can be realized by a complicated algorithm based on deep neural network. So even though this deep neural network is not very new, this can be realized because of the development in the computing system. So like a few tens years ago, the computer was so slow. So even if people theoretically can implement the deep neural network, it was really, really difficult to realize it in hardware. But now, due to the huge amount of improvement in the computing power, this deep neural network can be actually realized in hardware. So artificial intelligence can be very attractive in solving relatively complicated problems. For example, speech recognition and image recognition, they are good candidates of artificial intelligence and machine learning. So here I'm showing several photos, and as you can see, some of them are wolves, while some of them are dogs. But it's quite difficult for us to tell which are wolves and which are dogs, right? But if you have huge amount of images, and then if you can train an artificial intelligence with that data set properly, then actually artificial intelligence can tell which of these photos are showing dogs and which are showing wolves. Okay. Yeah. So this artificial intelligence will be quite useful when it is quite difficult for us to explain a certain question using mathematical expressions or using some logics. Okay. However, we have to think whether we can use AlphaGo-like artificial intelligence everywhere. For example, this is the photo showing the AlphaGo system. And as you can see from this at this slide, this AlphaGo system is actually using 1 megawatt, while human brain is consuming only 20 watt as power. So this means that AlphaGo system is consuming 50,000 more power or more energy compared to the human brain. So this means that the AI system is really, really power and energy hungry. So assume that all the smartness that we want to achieve should be processed by AlphaGo-like AIs. Then it will be almost impossible to provide all the required power or energy requirements, okay, coming from the AI hardwares. Yeah, everyone is suffering from COVID pandemic these days, but like artificial intelligence, COVID also has affected our daily life a lot. So now we have very limited social activities, so it becomes more and more difficult to, meet people face to face, and many people are relying on online platforms more and more, such as online lectures, online meetings, even online entertainment. right? So because of that, many tech giants companies, they actually have made huge amount of money over this COVID pandemic period. And they also recognize that artificial intelligence and machine learning are key future technologies. So they have like a Google, Apple, Facebook, Intel, they have acquired many different artificial intelligence startups over the last 5 to 10 years. So this one is showing the significance of the artificial intelligence in our future generation. Another key technology that we have to pay attention is the communication technology, which is called 5G. So in 5G, we can connect billions of devices through the network systems. Of course, we had many different communication systems, starting from 1G, 1G to 5G, but 1G to 4G, even though they can provide some mobility, their data capacity was quite limited. So it was quite difficult for us to connect so many devices through these previous communication networks. But in 5G, the data capacity and the bandwidth of the network is so large, so it is possible for us to connect billions of devices through these true 5G networks. Another key feature of this 5G is that we can actually realize smartness. Okay, so as everyone knows, smart city is a big theme that many, especially mega cities, are trying to realize, including Singapore, right? So in smart city, we actually want to deploy so many sensor nodes or edge devices. They can generate small amount of data per device, and then they also want to process it in a very smart way using artificial intelligence or machine learning. However, if you assume that all these sensor nodes and all these devices are sending the generated data to the cloud and ask the cloud to compute and send back the processed data to the sensor node and the edge devices, then the cloud will be the cloud service will consume huge amount of power, but at the same time, you also have to wait for relatively longer time to get the final answer, right? And at the same time, if you have no network connected to the cloud service, then even though you have huge amount of sensor nodes and edge devices, you cannot achieve smartness, right? So those are the big challenges that we have to tackle to realize smart cities. Actually, artificial intelligence can be implemented in many different layers. So we can have artificial intelligence based on the cloud service, which is mostly relying on software-based artificial intelligence. And we can also have artificial intelligence in the fog layer, or we can have artificial intelligence also in the edge devices. Okay, but we have we have a big achievement in cloud-based artificial intelligence. However, the realizing smartness for the edge devices are still not so mature. And then many hardware engineers, we are trying to develop proper artificial intelligence and machine learning techniques that can be useful for smart edge devices. Okay, then this slide is briefly showing the comparison between the cloud-based artificial intelligence and edge-based artificial intelligence. Of course, cloud-based artificial intelligence will be more powerful. So you can achieve face recognition, speech recognition, and complicated image classification, right? However, as I just explained, cloud-based artificial intelligence and machine learning will consume huge amount of power, right? So you can consider AlphaGo, right, as an example. However, but when you look at edge devices, IoT devices, you don't really need so complicated artificial intelligence. So you just need a little bit of smartness, but it doesn't need to be so complicated like AlphaGo. In that case, if you can realize machine learning or artificial intelligence in edge devices, then we can make decision locally, right? We don't need to communicate with the cloud, and we don't need to provide all the data to the cloud so that the cloud should compute and send back the decision results, right? And at the same time, since we can make a decision locally, we don't need to communicate so frequently, meaning the network loading will be also quite less. And then we can also save the power and energy dramatically. And edge computing is also more secure because you don't need to send all the raw data to the cloud, right? So you can just process at the edge devices as much as possible. So those confidential and very sensitive data do not need to be sent to the cloud. So these are the benefits. And in terms of hardware, because of this edge computing, we can also realize low power smartness. Okay, yeah. But of course, since we have limited hardware form factor and limited computing power, the performance of the artificial intelligence will be worse compared to the cloud-based artificial intelligence. Then we have to think whether we can still we still have to use a well-known neural network for edge devices. For example, this is just a kind of illustration showing a deep neural network, including multiple layers. But if you can, if you want to realize this deep neural network into a hardware, actually you need a lot of memory. Okay, so you can easily use up like hundreds of megabytes or gigabytes. But this amount of memory is quite difficult to be implemented in IoT devices or edge devices because they are consuming too much power. And IoT devices, they are usually powered by batteries or energy harvesting devices. So they cannot provide enough power. They can support this amount of memory and computing operation. So we have to find a way to simplify the neural networks so that the IoT devices can still have proper smartness, but without consuming too much power and silicon area. Okay. So when you look at neural network, actually there are not so many different functions that are happening. So in neural network, you can see that, for example, as you can see from this figure, convolutional layers are repeated. Even though their configurations can be different, they have multiple convolutional layer and a few fully connected layer. And when you look at the actual computing operation inside of each layer, multiplication and accumulation. So this is one of the most frequently computed function in neural network. So if you can realize this multiplication and accumulation in a very energy efficient way, then they can actually make your hardware extremely energy efficient, meaning you can make your edge devices and IoT devices smart without consuming too much energy. Okay, so that is what hardware engineers are trying to do these days. So in our group in NTU, we have also developed many different tiny machine learning algorithms implemented in hardware. So I will briefly explain a few examples. So this chip is showing a spike sorting processor for processing 128 channels. And those 128 channels are receiving, sensing the brain signals, okay, from your skull. And then the brain signal will be processed by this small spike sorting processor. And then this spike sorting processor can actually identify the source of a brain spike generated at a given time. Okay, so to realize this one, we have to come up with this novel hardware architecture, and then we have to implement all this hardware architecture in a very power and efficient way. And then we also implemented a classifier using a very compact and energy efficient algorithms. And then we also implemented a training algorithm so that even if we don't have huge amount of data, we can train this spike sorting accelerator, and then we can continuously monitor the brain signal and identify the source of the spikes that we are monitoring. And as you can see here, this chip is just consuming a few tens microwatt. So you can imagine that this spike, of course, I mean, this chip alone cannot operate. We still need microcontrollers or other CPU-like small systems. But as you can see from this power, it is so low, so it can be easily supported by batteries or some wireless power transfer. This is another hardware accelerator based on tiny machine learning algorithm for IoT devices. So so this chip is doing the gesture recognition. So we implemented 32 by 32 image sensor array, and we implemented motion detector and feature extraction cores and some classification, okay, processing units. So using this 1 millimeter by 2 millimeter chip, we can actually identify the gestures of your hands, okay, that are captured by a very small image sensor. Okay, so we put this one is just showing a lens for optics, but actually the actual image sensor that we are using is just this small image sensor arrays. Okay, and then we also implemented a compact neural network, which is not based on the very traditional deep neural network. So that by using a very small amount of data extracted from your hand gestures, we can realize a tiny artificial intelligence within this small chip, and then we can we can achieve successful gesture recognition. Okay, so as you can see from this table, this chip is consuming also less than 1 milliwatt. It is consuming only 213 microwatt while it is processing 30 frames per second. Okay. So this kind of tiny machine learning can be quite useful in some smart IoT devices that requires human-machine interfaces. And this is another version, improved version of the gesture recognition accelerator based on edge-based neural network. Okay, so this is a diphoto, and we implemented this chip based on 65 nanometer technology, and it consumes 184 microwatt using 0.6 volt, which is more power efficient compared to the previous version. And then this is a test board. I mean, the test system looks a little bit complicated, but they are only for testing. So actually we just need to test only this small test chip mounted in this socket. And in this gesture recognition accelerator, we developed edge-based neural network, okay, which is much more compact compared to the traditional like a deep neural network. So again, we are using the edge information of an object that is considered as a gesture. And then we are just processing this edge information through this compact edge-based neural network. And then by doing so, we can reduce the amount of data dramatically. And then we can also achieve a very energy efficient artificial intelligence. So this is the power versus supply voltage. So if you can increase the supply voltage, of course, it will consume more power, but it can process more frames. But even if you use 0.6 volt, you can still process 30 frames per second, which is the minimum requirement as a video. Okay. So this is the power breakdown. Okay. Another key issue that we have to tackle when we implement artificial intelligence or machine learning is the computing architecture. I don't know how many of you are familiar with computing architecture, but von Neumann architecture, this has been used as the traditional computing architecture, and all your PCs, laptops, even cell phones, they are mostly based on von Neumann architectures. So the main feature of this von Neumann architecture is that you have CPU or a microcontroller and separated memory elements. Okay, and then whenever you do some processing, you have to read data from memory and process it in a CPU, and then you have to write back the processed data into the memory, right? So because of that frequent data transfer, actually it consumes a lot of power, and then the data bandwidth that you can achieve is also limited. And we call that memory warp. This one is showing the latency and the energy, okay, depending on from where you are fetching the data. Okay, for example, if you are processing data inside of your arithmetic logic unit, then actually your latency will be less than 1 nanosecond, and then you're also just consuming just 0.1 picojoule, right, for one function, for example. But if you read data from register file for processing, then the latency will be at least doubled, and you can see that the energy consumption will be 100 times more, right? Yeah. But if you need data from SRAM, then latency will be similar, and power is also similar, right? Because register files and SRAMs are very close to each other. But let's assume that you are reading and writing data from external memory like DRAM. Then you can see that the latency is increasing dramatically, and also the power is increasing a few hundred times, right? So based on the very traditional von Neumann architecture, you have to sacrifice latency and energy very likely, especially when you realize deep neural network. Okay, because in deep neural network, to realize multiplication and accumulation, you have to read data and write data back to the memory extremely frequently. Okay. Then what is the solution that we are using these days? So this one. So this is GPU, right? Manufactured by NVIDIA. So we have to use this GPU that can accelerate computing performance, right? But this GPU, as you can see here, it is computing so fast, so it is generating so much heat. So you need this huge, this like huge fans, right? And still, they are not based on, they are still based on some processing element and separated memory element, okay, which is von Neumann architecture. Okay, but if you can somehow come up with a novel computing architecture that can make your neural network more energy efficient, then that can be quite beneficial in realizing artificial intelligence and machine learning hardware, right, without consuming too much power and energy. So, so as I just mentioned, this is the von Neumann architecture, which is the very traditional computing architecture. And people are trying to merge this memory and processing element as close as possible. And somehow, if you can actually merge your computing element and memory together, then that can be the most energy efficient processing element, especially for neural networks. Okay, so we call this scheme in-memory computing. So to do some computation, you are not reading data from memory and you are not writing data back to your memory. You are just doing the computation inside of your memory. Okay, so that is the main difference between the traditional computing architecture and in-memory computing architecture. So we, so as a circuit designing group, we are actually trying to come up with many different solutions for in-memory computing hardware. So this one is showing a very small SRAM, static random access memory-based in-memory computing accelerator. So this is the unit cell structure that we are proposing. And here, using this one, actually, we can achieve 2 femtojoule, yeah, 2 femtojoule, okay, as energy efficiency while running at 200 megahertz, okay. And we use this in-memory computing accelerator, and we tested the accuracy of a well-known neural network, okay, using MNIST data set, and we achieved a 96.2% accuracy, which is only 0.4% degradation compared to the software-based baseline accuracy. So this means that, oh, this in-memory computing hardware accelerator can be quite powerful when you employ this one in a tiny machine learning for edge devices and IoT devices. This one is another example, but mostly using digital signal, because the previous SRAM-based in-memory computing accelerator is using analog signal internally, but analog signals are susceptible to noises. So we replaced all the analog components by the digital components so that the in-memory computing accelerator itself can be quite robust to noises. So as you can see from this unit cell diagram, all the blocks, they are digital circuits. So we also implemented a similar digital in-memory computing accelerator, and then we could test it successfully. And this chip is showing a tiny neural network, including in-memory computing accelerator and on-chip training accelerator. So here, this one is showing the in-memory computing accelerator, and it is repeated 4 times because we have 4 layers in this tiny neural network. And then in this digital circuit part, we implemented multiple tiny convolutional layers together with on-chip training, so that you don't need to train using a computer. You can actually train using this chip itself. So you don't need like a wireless communication to send raw data to the cloud for training and receive the updated data. You can just process everything within this small 2x2 small chips. Okay, and then this can be used as a key component in artificial intelligence or machine learning for IoT devices and edge devices. Okay, so this is the summary. So next generation communication technology, which is 5G, is dreaming of connecting billions of devices through the network, right? So the main reason that we want to do that is to achieve smartness, right? So we can achieve smart societies, we can achieve smart power grid, we can achieve smart nations, right? So they can, so those kind of themes can be achieved when we can have true 5G network, okay, after connecting billions of devices. However, current software-based artificial intelligence performance is quite limited by the power and the hardware. At the moment, we are not using AI everywhere. So that's why a software-based AI is still can still provide decent services, but if you have billions of electronic devices that are requesting smartness based on software, then the power consumption cannot be tolerable, and the hardware to realize the software-based artificial intelligence will be also a big problem. Okay, so to mitigate this issue, many people are trying to realize tiny artificial intelligence, especially for IoT devices and sensors. So this tiny AI is not for supercomputers. It's not for AlphaGo. It's only for very small devices that requires a little bit of smartness. Okay. So to achieve this one, energy efficient tiny AI hardwares need to be developed. Okay, and then once we can have this energy efficient AI hardware, then we can actually implement artificial intelligence in billions of smart edge devices, and then we can really achieve true 5G network and the smart society and the smart nations. Okay, so that's the end of my presentation, and thank you for your attention.